Hello and welcome. Let's try to solve another Leetcode problem. 2392. Build a matrix with conditions. Let's first try to understand the problem. So we have two arrays. So what is the row conditions? It means the conditions of the row. So the first number should be above the second number. Let me make it clear. So for example, we have 1 and 2. So 1 should be above 2. So this is 1 above 2, right? And 3 should be above 2 as well. As you can see, 3 is also above 2. So this is according to the vertical direction. So it means 1 above 2, 3 above 2. Another one is according to the horizontal direction, maybe left or right, but we're going to use the left first. So the column condition is that 2 is at the left of 1. As you can see, this is 2, it is at the left of 1. And 3 is at the left of the 2. As you can see, 3 is here, 3 is at the left of the 2. So this is our conditions with the row and column, but we have to meet the conditions. And what we're going to do, we need to meet some conditions and to fill in a matrix, and the row and column should be k. So this is the row and column, and this is the matrix. Now we are going to fill in the row and column numbers. Basically it is 1 to k. So the number is going to be 1 to k. So we're going to try one by one. We can try to fill in according to the row first and then column, or we can fill in according to the column first and then the row. It is both okay. But no matter which way we're going to use, we have to prepare such kind of sequence. So for the sequence, let's just try to use this one. So 1 should be first, and then we're gonna have 2. So this is let me make the drawing here. This is 1, and then we're gonna have 2. And 3 first, and then we're gonna have 2, right? So here gonna be 3 first, and then we're gonna have 2. So this is according to the vertical direction. It is just according to the row. So it means 1 first, then 2, 3 first, then 2. So we can have two combinations. It is like 3, 1, 2, or 1, 3, 2. But definitely 2 should be the last row. As you can see, this is a topological structure for the row. And similarly, for the column, it is also a topological structure. So while we are building the row topological structure, we are building it from the 0 index to k minus 1. And similarly for the column index, we're going to build it. Similarly for the column, we're going to build it from 0 to k minus 1. So let's just try to finish the topological for the column conditions. 2 first, and then we're gonna have 1, right? And then 3 first, then we're gonna have 2. So 3 gonna be here. So this condition, this area is just about the column. So this means there's only one condition, that is 3 to 1. So we can have different ways. So what about we just fill in the row first? Maybe we're gonna choose this combinations 3, 1, 2 according to the answer 3, 1, 2, right? So the first row must be 3. But what about the column? So this is the column. The first one gonna be 3. So 3 gonna be here, and the second row gonna be 1. But where should be the 1? So the 1 should be at the third column. So here gonna be 1 because it is the last column. And now the last row is 2. But where should be the 2? At which column? 2 should be in the middle. So 2 should be here. And this is the final result. It seems the problem has already been solved by using the topological sort. It seems we have to build a topological sort by the row and by the column. And this is by the column. It has to be starting from index 0 to k minus 1 according to this direction, and similarly for the row according to the 0 index to k minus 1. You can also prepare the topological sort from k minus 1 to 0, but that would be much difficult for the coding. Yeah, because if the best way to coding for the coding is just starting from 0 index, it's gonna be easier. Otherwise, you have to, yeah, I think it's really difficult to coding if you start from k minus 1 to 0. So you have to check the last column and then go to the first. Yeah, so according to the custom way of solving the problem, we're gonna start in from index 0 to k minus 1. I think this is gonna be much easier to build the topological structure and fill in the matrix. Now let's just try to solve it. As we need to prepare two topological sequence, so we're gonna use a function. I'm gonna use a topological sort function to prepare that. Yeah, basically inside there are two topological functions. So I'm gonna use a condition. So condition is I gonna put those condition inside, and I gonna get the row sequence. And if I put the column conditions inside, I got a column sequence. Yeah. Now I want to build this structure. I'm gonna use a graph and integrate as always for my template of topological sort. So inside it's going to be adjacency list for the graph, and integrate it's going to be an empty array and times k. K is the number of vertices. K is the number because we have the number just from 1 to k. So we have to build a k times k matrix that contains each of the numbers from 1 to k. We have to build the structure. So for this example, 1, 2, 3. Otherwise we just need to return an empty array if we cannot build it. Yeah, except for that, all the numbers inside the matrix should be 0. As you can see, it is just like this. Yeah, and also you can see the matrix, the k is just 400. It means for the topological sort it should be okay because it is basically the time complexity. Basically, it is the OE plus V, the number of edges and the number of vertices. Vertices is 400, and the number of edges is also 400. As you can see, the topological structure, it is not so complicated. I mean, it is just all 400. Now let's just try to build the graph first. So I'm gonna choose any two edges. So for AB inside the conditions is my row or column conditions, and I need to have a sequence. So my sequence is I gonna check 1 first and then 2, check 3 first and then 2. Yeah, so this is according to the row conditions, and similarly for the column. So this means for my graph, I'm gonna check A first, and then I'm gonna append B, and for the integrate, I'm gonna check B plus equal to 1. Now we also want to check the column if it is the same. It is exactly the same, 2 first and then 1. It means we're gonna starting from the left to the right and from the top to the bottom. Yeah. Now we want to prepare a queue. I want to prepare a queue and a sequence as my result. So queue gonna be the queue, and I for I we enumerate the integrate. So if this v equal to 0 and I not equal to 0, and this is because I didn't prepare the vertices from 0 to k minus 1. I just prepared to 1 to k. This is why I have to check this I should not equal to 0. And similarly for here, I need to use k plus 1 because I don't want to, because basically I don't need to check the index 0 because I didn't use it. Otherwise I have to check it yeah, from other places. Currently I just check the vertices 1 to k, yeah, without 0. This is why I need to check it I should not equal to 0. And for this sequence, I'm gonna set a empty array. Now I'm gonna check the queue, while queue, I'm gonna pop it out. So now it's gonna be equal to q dot pop on left, and I want to put it inside of the result and put this node inside, and then I'm gonna check the neighbors with this node. And for the integrate for this neighbor is going to be -1, and if the integrand for this neighbor equal to 0, then basically I want to put it inside the queue. Yeah. So if I can build a sequence of this result, I'm going to return this result only if the length of the result equal to k. Otherwise, I will give a 0. So this means it is not possible. I will give a 0. If I can get a sequence, for example, this result, it may be for the columns, it may be like 3 to 1. For the rows, maybe it is like 3 or 1, 2. Basically, I want to find such kind of sequence, and then I'm going to use the sequence to build a matrix. And finally, I'm going to return this matrix. Now, I want to check if I can build everything. Okay. So I want to check if topological sort with row exists. So I'm going to use if it does not exist, and similarly topological sort with the I think I need to copy the row conditions and column conditions. So here going to be the row conditions, and here going to be the column conditions. I mean, if either one of them is empty, basically it means it is not possible, and if it is not topological sort with column conditions, so I need to return an empty array, because according to the question we need to return an empty matrix, and an empty array is the same as empty matrix, so this is okay. We don't need to return something like this. Otherwise we're gonna check it. So we can start from the row and then to the column, or we can start the column then to the row. It is both okay, but we need to remember the positions for the row or column. So we need to prepare a row position. So this is just a row position map. We need to remember the position from where it is, and then we just need to fill in the column one by one, and for each of the column we're gonna find which row it is. So for here I'm gonna remember the row, so it's gonna be the let me use x is just a value with row I'm gonna use r. So for rx in enumerate with this row. So I want to remember the position of each row. So for example, here the index r, for example, this is gonna be starting from 0 first. But for the first one, for the row, I'm gonna have a number. It is 3. So this means whenever I find a value 3, I should know it. The position for the row of this number 3 definitely gonna be row 0. According to this way, I can remember all the positions of my row, and then I'm gonna enumerate the column. But before that, I want to prepare a result array. So it's gonna be 0 times k for r in range k. Basically, I want to fill in this matrix result, and finally I'm going to return this result. Now I want to enumerate the columns. So for C, I'm going to use y. C is the column index, and y is just a value in enumerate the columns. Definitely, if we cannot get such kind of row condition, topological sort of a row or column, we're gonna return an empty array. Otherwise, definitely we can get the result. This means that sometimes we can have a loop. So this is the topological structure. Like that. So if we have a loop, definitely it's gonna be wrong. So if we have a topological structure and it is equal to k, it means we can get a sequence. If we can get a row sequence and we can also get a column sequence, definitely we have a possible result. because there's no relationship of each row and column. There's only relationship with rows and with columns. So this is why definitely there is an answer. Yeah, if there is a relationship between row and column, we are not sure if we have an answer. But there's only conditions with rows, and for those we have a sequence. And for the column, we have a sequence. And we used all the numbers. Definitely we have a possible result. Now we want to prepare the column. Yeah, so for the result, we need to know the position of the row. So it is the row position. As I explained earlier, we need to know this value. And now we have the row position. And what is our column position? So it's going to be C, because this C is for the column condition. From the beginning, this is going to be the first column. And then we're going to find this number 3, it's going to be in the first row. And we want to fill in this number. So this number is going to be Y. It is 3 for the first one. And according to this way, we will fill all the numbers. According to this kind of a logic, for each of the column, we want to fill a number. We want to find which row it is. Or you can do it reversely. You can prepare a column position and then prepare the row. It's also the same. It always depends on your preference, but the result is going to be the same, because no matter which kind of result, if you get a topological sort, definitely it will be true. Even though the answers may be different, but it is a topological structure and it's going to be true. Yeah, if everything's okay, definitely I'm gonna return my result. It should be okay. Now let me run it to check. Yeah, I did something wrong. I think I forgot to prepare this row and column. Yeah. So maybe I want to take it out here. So for here, I'm gonna prepare row and column. So this is my row, and this is my column. And I want to check if not row or not column. Yeah, I'm gonna return an empty array. Otherwise, I want to get my result. Yeah, as you can see, it works. Now let me submit it to check if it can pass. Yeah, as you can see, it passed and it's pretty fast because time complexity is only O(n). Yeah, because number of the vertices is 400 and the number of edges is also 400. So according to the topological structure, it is like there's only k numbers because there are only k numbers. So if we want to build this structure, the edges should also be k. Yeah, let's just check the row and column conditions. Let's see the length of the row and column. It is not. It is 10 to the power of 4. Yeah, so this means the time complexity gonna be k plus 10 to the power of 4. It's gonna be 10 to the power of 4, not 400, because the column is gonna be a maximum 10 to the power of 4. So we're gonna use the edges. The row and column length is just the edges. We're gonna use 10 to the power of 4 as the final time complexity. Thank you for watching, and see you next time.